I'm Dr.Anitha Rexalin Devaraj, Associate Professor, Department of Physics, Amit University. Today, I'm going to tell about superconductors. Under this topic, we are going to see about introduction, superconductivity, and what are all the properties of superconductors, types of superconductors, and applications of superconductors. Superconductors are the materials that have no resistance to the flow of electricity. And it is one of the great frontier of science industry, and it was discovered by the great Dutch physicist Ernst on April 8, 1911 at Leiden. He was first observed this superconductivity in mercury, and when it is cooled to the temperature of liquid helium. So under a certain temperature, the complete resistance of mercury will vanish, that is disappears. So because of that, this superconductor is also called liquid helium oneness effect or superconductivity. So for this discovery in 1913, Oneness received a Nobel Prize. Superconducting materials have extraordinary electrical and magnetic characteristics. And also they have important applications in the field of engineering and technology-oriented fields. Next, we need to know what is superconductivity, and that is a proper definition. We have to know that, and it is also called supraconductivity. That is, initially superconductivity was called supraconductivity, and superconductivity is the phenomenon of sudden disappearance of electrical resistance in a material when it is cooled below a certain temperature. Next jargon word is transition temperature or critical temperature. It is represented by the letter T suffix small c. So it is the temperature at which the material at normal conducting stage becomes the superconducting stage. That is, at a particular temperature only, the normal material will become a superconducting material, and that particular temperature is called transition temperature. So here we have represented the transition temperature of some elements like indium, mercury, niobium, titanium in Kelvin. So some properties of superconductors are it has zero electric resistance. That is, if the resistance is zero, the current flow will be infinite. And at a particular temperature, that is Tc is equal to zero, at this condition only, zero electrical resistance is holds. At that particular point only, conductivity will be infinite for superconductors. And the next important property is Meissner effect. So in Meissner effect, we can see the expulsion of magnetic field, and we'll see it later in an elaborative way. And the third property is critical temperature or transition temperature that we have seen already. And critical magnetic field is the another property, and below the Tc, that is transition temperature, when you apply strong magnetic field, superconducting property is completely vanished. So at that particular magnetic field, we can call it as critical magnetic field. In the same way, we can define critical current also, which has been given as a loss point, that is IC. So by applying a very high current, superconductivity property can be vanished easily. So at that particular current, we can call it as critical current. And two more properties are there. One is represented by Josephson currents or Josephson effect, and another one is persistent currents. So persistent current is a steady current which flows through the superconducting ring without any decrease in the strength as long as the material is in a superconducting state. So that is called a persistent current. And persistent current, even after removal of magnetic field, will exist on a particular wall. Next is an important invention that is done by Meissner. He is such a wonderful scientist, but the sad thing is all other scientists who have contributed a lot for superconducting materials invention has received Nobel Prize except Meissner. But Meissner effect plays an important role in the property of conductivity, that is superconductivity. So magnetic fields of lines will be represented in arrow lines, and they are excluded from the superconductors when the temperature is reduced below its critical temperature, It has been shown in the figure. So superconductors expel magnetic field and hence it repels magnetic fields or magnets. So this repulsion can be more stronger than gravity as well. So because of that, it will alleviate. So most of the electric trains will alleviate. You can see the fastest trains. It will be alleviate upon the rails and it will go. It works under the principle of magnetic leviation. So it is one of the most fascinating and manifestation of superconductivity. And now you can watch this video so that you can get a good idea about Meissner effects of magnetic leviation. So this is the scientist called Josephson. In 1962, he found the tunneling effect of superconducting electrons. So because of that effect is defined by his name, Josephson effect. And tunneling of superconducting electron pair with opposite sign and momentum through a thin insulating barrier between two conductors. Because of his name, it is called as Josephson effect. So for the discovery of this Josephson effect, David Josephson received a Nobel Prize in 1973. And next is the important backbone theory of superconductivity, which is called as BCS theory. Bardeen, Cooper and Schrieffer. These three people are the basic pillar of this theory. So because of their discovery, the theory called by their names BCS theory. And they have shared their Nobel Prize in 1972 for the discovery of BCS theory. An electron form a pair which can be called as Cooper pair and which will be propagating through the lattice in any particle or any solid or liquid, anything. So that can be called as Cooper pair. So it plays an important role in a BCS theory. And the propagation of Cooper pair is without any resistance because of the electrons move in resonance with the phonon. So the interaction between the electron and that phonon is known as electron-phonon interaction. So this will be explained briefly in BCS theory. Next, we need to know about the classification of superconductors. We have two kinds of superconductors, type 1 superconductors and type 2 superconductors. In this figure, red color line represents type 1 superconductors and the dotted two lines will be representing the type 2 superconductors. For type 1 superconductors, material loses its magnetization suddenly and the magnetization will be gradually reduced or lost by type 2 superconductors. And type 1 superconductors are also called as soft superconductors and type 2 superconductors can be called as hard superconductors. Type 1 superconductors exhibit Meissner effect, but for type 2 superconductors, they don't exhibit Meissner effect. And all the diamagnetic materials comes under type 1 superconductors. And for type 1 superconductors, it contains only one critical magnetic field that is represented by the letter Hc. In the red color line, you can see only one Hc will be present. But for type 2 superconductors, we have two kind of critical magnetic fields which is represented by the letter Hc1 and Hc2. Hc1 is the lower state or lower critical field and H2 will be the higher critical state. And between these two, we are having mixed state in type 2 superconductors, but for type 1 superconductors, we don't have any mixed state. An example for type 1 superconductors are lead, tin and mercury. Type 2 semiconductors, example for type 2 semiconductors are niobium tin, niobium zirconium, niobium titanium, etc. And one more type is also there, high temperature superconductors. So if the superconductors temperature will be greater than 20 kelvins, then it is called high temperature or high transition temperature superconductors. In 1986, Muller and Bednarz discovered this high temperature superconductors in ceramics. For that, they have received the Nobel Prize as well. So some of the high temperature superconductors and their temperatures in Kelvin has been given in this table. We can classify into two types, low temperature superconductivity applications and high temperature superconductivity applications. So for low temperature, we know that MRI, NMR all has been comes under this category, and particle accelerators electrical power transmission, all this comes under low temperature superconductivity applications. For HTS, that is high temperature superconductivity, HTS based so many systems will be there that comes under this application, and Holbrook's superconductor project, and then trapped field magnets, these are comes under high temperature superconductivity. And the applications of superconducting material has been pictorially represented in this slide. So by seeing this slide itself, you can remember what are all the applications of main important applications of superconductors. You can easily remember. Since we are related to nautical field, applications of superconductors in ship is much important for us to learn about that. So we need to know specifically about the applications of superconductors in ship. So I am going to mention just 1 or 2 points, and you have to search more applications, and you have to apply while you are on board on ship. So superconductive digitizers enable ship self-defense radars in sense of small echoes from sea skimming missile threats. So US Navy has been used this superconducting digitizers, and it is licensed as well. And some of the advantages of superconductors are superconductors can carry a large quantity of energy without any heating loss. We know that when a particle allows the current pass through it, definitely it will be get more heat or heat. Because of the heat, Joule's heating loss will be there for all the conductors. But for superconductors, since it doesn't have any resistance, definitely heat loss will be nil. And superconductors able to generate strong magnetic field, and it has more applications in medical imaging techniques. And new superconductive films may result a miniaturization. And superconductor increased speed in computer chips, and some disadvantages are also there. Superconductors still do not have shown up in most everyday electronics. And the first point is actually superconducting materials conduct current only at a particular lowering temperature. But nowadays, this is also can be removed, because at the room temperature, some material will exhibit superconductivity. So at room temperature also, superconducting materials are there. That is a new invention, frontier invention in the field of superconductivity. So many people receive Nobel Prize for superconductivity except Meissner. So it is really a sad part to tell about that. Thanks for watching. See you in the next video.